Good evening, ladies and gentlemen. Welcome to WeatherBrains episode number 790 for the 8th of March. Welcome to Meteorological Spring. Yes, it's the pre-show, that magical time of the program where we do three things. We share boring personal stories, humorous anecdotes, and we say outrageous things. Yes, indeed. I think the chat's working tonight. Yeah, buddy, we're good to go here. So let's get the embed code going. A little late here tonight. We got 3 minutes. We'll make it. We have cats that live here. We've had one black cat for, I think, 12 years. So now we have 4 cats. We have 2 new ones out. We actually 3 new ones. So I had to go back there and feed all these cats. We're going to go broke feeding these things. All right, so let's get everybody on the show here so they won't think that we forgot them. And then we'll get this sucker started. Monday night weather party, indeed. I think that Aubrey is out tonight. And I know that Troy is still out tonight. He is still recovering from the Arctic blast. And he had a lot of water damage, and it's just been a really, really, really rough ride for Troy. We just hate to hear that, but he thinks he can join us next week, which will be good. We ought to just let him have the whole show and talk about his experience in the deep freeze. I got some, looks like some maybe severe weather setting up for the weekend across parts of Texas and Oklahoma, Arkansas, maybe Louisiana. And it is that time of the year. It's been remarkably quiet where we are and will be this week, but looks like the pattern starts to heat up a little next week, and we'll talk about that in the weather roundup. I saw where Mr. Nate was flying on Delta Airlines.
A year
back
ago.
in the air. Back in the air. So you drove to Texas and you flew back, huh?
No.
No?
No, that was a year ago. A year ago today, the last time I set foot on an airplane.
Okay. I thought that was your current ticket to ride.
As a matter of fact, that aircraft has been retired. The pandemic accelerated Delta's retirement of the MD-88 aircraft, and so that critter is no more, unfortunately. Well, I mean, the plane is fine. I'm sure it's sitting in a boneyard somewhere, but no, I haven't flown in a year, and it may be months before, probably going to be months before it happens again, unfortunately.
We have a large number of Delta aircraft at the Birmingham airport.
Mm-hmm.
Bill, have you seen those out there? They're just
it's crazy.
It's like this
down there in
Delta parking lot. They've been there for a year. Yeah. So hopefully
they're nice and close to Atlanta, just in case they want to put one back into service in the short term. But
I think we should rent one as the WeatherBrains corporate jet, and just Nate's a pilot. He can fly us. He can take that sucker. And
I think they'll do that.
I'm not rated for that aircraft. But
what, Bill?
You think they'll let us do that without checking our credit on the corporate American Express?
We'll have to get our credit limit raised a little bit here.
Yeah, I don't think 300 is going to get us $300 is going to get us very far.
No, but it's a start. You got to start somewhere.
That'll buy you one seat in first class from Birmingham to Atlanta.
No, probably won't.
That's
a good thought, Nate. But
I had a great experience with Delta here. We were going, I want to say, to Denver, or I don't know where we're going. And the agent said, hey, come back here. And we went behind the little lines there, and he went back there and he got us in first class. I'm thinking, okay, this is working for me. I mean, I said, I feel guilty. He said, no, it's okay. You fly a lot.
Famous.
You're a good guy. You fly a lot with us. We appreciate our good customers, and we had a couple of seats. It was just 2 of us. My wife wasn't there. It was me and my youngest son going to a baseball game somewhere. Mm-hmm. So we've had great experience with Delta.
Yeah, they're good. I like their customer service the last several years. They've been good.
Yeah.
That's who I fly almost exclusively, just for the loyalty points. Because if you don't have status anymore, you have trouble, getting an overhead or doing anything you need to do.
We have Delta's made Raleigh an RDU a focus city. So sort of like a mini hub almost. And although that has been reduced a little bit, they announced last week that they're sticking with Raleigh as one of their 2 focus cities beyond their natural hub network. And so it sort of naturally, they fly more flights out of RDU than anybody else. And so I wind up on Delta planes and have had to make the call to customer service a couple of times to get me out of some sticky spots and whatnot. So
Hit me.
Isn't the other focus city Austin, Nate? This looks like a pattern.
Used to be. I think they
used to be.
I don't know which 2. I know they picked RDU. They had like 6, and Austin was going to be one. Nashville is going to be one. There are a couple others, but where I go too, it just happened to work out. Like there's a nonstop every day to Hartford. We have a station in Hartford. There's a nonstop every day to Philly. We have a station in Philly. Of course, lots of flights to New York. They have a couple nonstops every day to Fort Lauderdale, which is actually closer to our station in Miami than the Miami airport is. So just it naturally sort of plays out that way. And the intersection of our travel policy is such that we prefer a single nonstop flight, even if it's a little more expensive, than a 2-hop flight. Although they'll let you take the cheaper 2-hop flight if you're willing to accept the risk that you get stranded and all that kind of stuff. But
all right, let's get this thing going here.
I tend to find that
Sam and Daniel, can you guys hear us okay?
Perfectly. Can you hear me okay?
Okay.
Yes. Excellent.
Yep. I
Sam, you good?
Got the audio.
All right, so
liners,
James, are you good with the intro and the spot?
Yeah,
going
I've
into
got the audio liners lined up. They are lined up to. The liners are lined up. I'll put it that way. So let's get the recorders going, and we'll see if we can make this puppy fly. Thanks to Jen for being the voice of the show. It's great having a professional. Here we go.
Thank you.
Here we go in 5, 4, 3, 2, 1.
WeatherBrains is brought to you by Midland Weather Radio. Every home, school, and business should have a NOAA Weather Radio, the official voice of the National Weather Service. And the AMS Weather Band.
Join the American Meteorological Society by becoming a member of the band. The AMS Weather Band is a global community of weather enthusiasts dedicated to learning and sharing their love of science. Visit amsweatherband.org to learn more and join the band today.
This is Weather Brains, the weekly show all about weather, episode number 790 for March 8th, 2021. We are now into meteorological spring. I just like saying that. Jen, does it feel like spring where you are in Ohio this evening?
Finally. Yes, it's upper 40s right now. We got to about 60 today, and we're going to see mid 60s the next few days. So that is good. And then we get chilly again, but I'm going to take the next few days for sure. But yeah, finally here. Hopefully no more snow, but there may be a little bit this weekend, a little mix as last I saw. So
we might do 80 down here later this week. So it's starting to look and feel like spring. Everything is blooming, the trees and the flowers. I see Nate is back in North Carolina tonight. Nate, how was your trip?
It was good. We picked up some sort of a cold or something on the way home. I think had to go get the old COVID test, but we all 6 of us came back negative. So we're good to go. We're just dealing with a cold. Not sure where that came from, but we'll take it. Otherwise, we're doing good. Nice to be home.
Good. And we should mention Troy is still recovering from his incident involving the winter storm, broken pipes, just a mess. And he says he will be back with us next week. Aubrey is tied up this evening. She cannot make it. Hopefully Kim will join us here soon. But Bill, let me flip it over to you. You bring in our guest. I'm excited about the show tonight.
Yeah, James, I'm really excited about it too. First, our guest panelist tonight is a suggestion of a friend of the podcast, Jay Farlow. He is the warning coordination meteorologist at the National Weather Service in Indianapolis. Sam Lashley, thank you for joining us.
Yeah, glad to be here. First time on the show, and I'm really excited to be here. Thanks.
Well, we are too. And you've got 2 big things coming up. One you know about, and one you're probably not thinking about, a little basketball tournament in your backyard here in the over the next few weeks. So that's got to be exciting.
It is exciting. I'm still trying to get tickets, so I figure between one of all those games, I can get in somewhere. But yeah, we'll be working with our partners here around Indianapolis and Central Indiana, getting ready for that, and then our big severe weather symposium that we'll talk about later coming up. That's a huge deal, as Mr. Span there was a guest in 2018, so it's a big deal for us.
Well, we are really excited about hearing all about the symposium. That's the main reason we've got you here tonight. We'll do that after the recorded segment, so we'll make sure to leave plenty of room for that. But also to hear, some other things about your career in weather and, things that your office is focusing on. And I was glad to hear that you were actually interested in tonight's main topic. That worked out to be a good marriage tonight. So please come with plenty of questions and comments for our guest weather brain too.
Will do, for sure.
Tonight's guest weather brain earned his PhD in atmospheric and space sciences from the University of Michigan. He was part of the team that transitioned the space weather modeling framework from research to operations at NOAA's Space Weather Prediction Center. That's the first such transition of a physics-based numerical geospace model. He is currently an assistant professor at the University of Texas in Arlington. He was the developer for the SWMF and studies both the physics of space weather and advancements in space weather forecasting. Dr. Daniel Welling, welcome to WeatherBrains.
Hello, WeatherBrains. How are you all doing?
Well, we are probably what, James, would you say tired, worn out, hectic, frenzied? That's what I am. I don't know about everybody else, but I'm coming in on
all of the above. Yes.
But you've been that way since 1979, so it's no
73, 73. Yeah. That's and it's true. I've not slept much since 1973. I really haven't, but it's okay. I am not complaining. I love everything I do.
Well, that's exactly right. And Dr. Welling, that's the last time I'll call you that because you officially gave me permission to call you Dan.
Yeah.
So, but I want to get that honorarium in there. And in the intro, I mentioned that you were part of the team that transitioned this space weather modeling framework into operations at the Space Weather Prediction Center. Talk about what it is and what it does.
Sure. It's quite a bit of a story, so I'll try to summarize it as quickly as I can, and don't be afraid to tell me to shut up if I go too long.
We got all night. Go, just take your time.
We've gone till midnight, 1 a.m., whatever.
Oh boy. So yeah, the fundamental problem we're trying to address is that of space weather, and it's of course starts at the sun, where when we think about the sun, we think about light and heat. But it's much more than that. It's magnetic field, it's X-rays, and it's a constant flow of charged particles from the solar atmosphere throughout the solar system and past the Earth. And this tends to interact with the Earth's magnetic field. The fun thing about charged particles is that they don't just interact with the Earth's atmosphere, but first encounter the Earth's magnetic field. And so you get an electromagnetic interaction, and that can drive currents, that can drive the aurora, and the whole system from end to end is this multi-scale, multifaceted system that's really challenging to study. So I've been very privileged to be one of the developers for the space weather modeling framework, which came out of the University of Michigan in the early 2000s. And the goal was to treat the space environment from a numerical standpoint the same way it's being treated as in a scientific standpoint, right? You have a solar physicist, you have a heliophysicist, and people who are really concerned about the evolution of the solar wind from the sun to the Earth. You have upper atmosphere folks, you have magnetosphere folks, and those can be broken down even further to radiation belt specialists and magnetic reconnection specialists, which are really in the weeds with the electromagnetism in space. And so the SWMF kind of is a framework. It ties all these regions together by allowing users to plug in models that only simulate a certain region, and then have all those models talk to each other and communicate, so you get this coherent, fully self-consistent simulation of the space environment. So it's one of several models out in the field used to study the space environment, space weather. And around, let's say 2010, NOAA, specifically the Space Weather Prediction Center, SWPC as we say, really wanted to bring in a numerical model into operations. They've had a few empirical models and things like that, but they really wanted to start forecasting space weather because as we can talk about at length, the effects of space weather are really quite dramatic as our technology becomes more and more vulnerable to them. So they held a bit of a competition where they picked certain historical events and they invited different researchers, research teams, I should say, from the field who had different models to simulate these events. And everything was kind of hosted by NASA's Community Coordinated Modeling Center, or CCMC. So it was this big validation challenge. Who could predict the perturbation of the Earth's magnetic field on the ground with their computer models? And NOAA and CCMC looked at all the resulting data and the resulting forecast, and they had their own metrics and validation. They scored everybody, and they also looked at the quality of the codes, the ability of the codes to be transitioned into operations, because you can't just bring anything into operations. It has to be robust. It has to be coded clearly enough so that anybody, well, not anybody, but the people running it at NOAA's climate prediction centers would be able to work on it and change and fix things if needed to. And they took all this into account, and they picked the space weather modeling framework. And I was at the University of Michigan at the time as a research scientist. And I was a postdoc at Los Alamos and had done my PhD at Michigan, and I kind of jumped on the team just as they were starting to expect the final decision from NOAA. So at the time, this was really exciting for us. We were doing a lot of last minute development for features that we think could be useful. And we got the call and told that we were going to start a 5-year partnership with them, where myself and another scientist, Gabor Toth, would be supporting this transition to operations. And that was an experience. I don't think I've learned more about how forecasting is done than I did when I was on that team. And listening to your podcast the last couple of weeks and hearing some of the themes from Louis Uccellini and the other people on here, hearing their responses to questions, every time I'd hear those, how they respond and how they talk about forecasting and building these things up, I'm just thinking, yeah, that was us. It started with just NOAA would come to us. We would have a monthly meeting, and they'd just say, we tried this with the code and it didn't work. Okay, well, that's, we can add a new output or a new configuration to help with that. And then we got to the point where we were really in the weeds with the transition when they were on the NCEP machines, the National Center for Environmental Prediction. And the big milestone there was that your code has to run uninterrupted with no human intervention for 1 month before it can be brought online. And so every day we're kind of waiting for that email. Well, guys, last night it failed. We did pretty good. We made it a while. And I remember the first real problem we had. You think about these codes, you think about what's going to set things off and make things crash. And you think about, well, of course, the biggest solar flare or something really weird we didn't think about. And it turned out to be quiet conditions. It was actually that the code was running during a period where the solar wind was so slow and so quiet that the density of the plasma of the particles in near Earth outer space dropped so low that the code had to take very, very tiny time steps. You know, the wave speeds got really high, that kind of, you know, in the guts of the code there. And it was, we figured it out, you know, with a pretty quick turnaround, but it was just funny. It wasn't the big stuff that stopped the code. It was like the most boring conditions that caused problems. So we finally went live circa 2016. They were able to announce the code was running 24/7 online, and we continue to support it. You know, I'm now at the University of Texas at Arlington. The folks at Michigan, I always say UMich, but continue to support that project. Every once in a while, an email slides my way, and I get to chip in. The other quick anecdote that I think you guys will really appreciate about that is how different forecasting looks from the point of view of an academic or a model developer versus the forecaster in the room. And that was a big revelation to me. The story is that space weather has a lot of these numbers called geomagnetic indexes. And one is called KP. And if you look it up, it's a long German word that stands for, it means that like the one planetary number that's meant to characterize space weather. It's kind of like a Richter scale for space weather, but if you're a scientist, it's almost completely useless. It's just so coarse, right? And the folks at NOAA, they would always talk to us about KP. How are you calculating KP in the code? How do you do it? And we would say, well, we use this algorithm to do it. And they said, well, could you make it so it does it the exact same way that the observations do it, the exact same way? And we would sit there in the office on this telecon and look at each other and just think, the way we do it is so much more comprehensive. Why don't you just use that? It's perfect, right? And it was kind of banging our heads against the wall, really didn't understand it. I went out to the Space Weather Prediction Center a couple of weeks later for a site visit, and I really, for the first time, talked to the forecasters. And I asked about this. I was very frank. I said, "Look, from my point of view, I don't get it. I don't understand it." And the one forecaster said, "Look, here's the deal. The reason we need you guys to calculate it exactly the way it's observed is because if there's a difference between the model and the observations at that point, we need to know, is the model wrong, or is there something wrong with our observation? Is there something wrong with our data stream? And if you're adding in extra variables there, it is one more unknown that we have to deal with on the fly." And so I went back and to Michigan, you know, explained that to my colleagues, and well, I guess that's true, you know, but but that was a really eye-opening experience for me. I really enjoyed that a whole lot. So I guess that's kind of a short intro on my really direct experience with space weather in terms of forecasting. But we're doing a lot of really cool stuff at UTA. NOAA continues to do some amazing things with space weather forecasting. It's a field that envies you guys like you have no idea. We wish we were at the point where we were doing ensemble forecasting. We wish we had the cone model. We wish we had that graphic that could communicate space weather forecasting and prediction to the public like you guys have. The meme in the community is that space weather forecasting is 50 years behind, we say, terrestrial weather forecasting. And I don't think it's 50 years anymore, but we have a ways to catch up. So I'm really happy to talk about all those things, and I love this topic a lot. It's a lot of fun.
Well, careful what you ask for, Daniel, with the cone. We're still trying to make it work, but you're absolutely right. It is fascinating to watch that. And I know, Sam, that's a big topic for you is ensembles and deterministic forecasting. So, you know, talk about that for a second, Sam. You know, why, you know, we get into it a lot on here, but ensembles are really critical in understanding what the range of possibilities are. talk about that a minute. And then Daniel, you tell us how that's playing into what you guys are doing, if at all.
Yeah, I mean, ensembles is where it's at. One single deterministic model obviously cannot handle all the variables in the atmosphere. And these ensembles, so many runs now, the computing power that can, throw in all the variables and really give us that best guess solution on what's going to happen is fantastic. And one area we're seeing ensembles that I think are really going to take us next level is with hydrology and river forecasting. For years, this science has really never changed, and now we're getting projections of that cone of where these rivers may go. And emergency managers really, they want to know what's the worst case scenario I need to plan for, and these ensembles give us that range, best case, worst case scenario, and most likely, and that really helps them make decisions. So that's where the future is at, and I can't wait to see where we go from there with weather forecasting.
I completely agree that that's the future. I wish we were as futuristic as you were. Our field is slowly, painstakingly getting to the point where we're taking advantage of ensembles. I'm very proud to say that I was part of one of the co-authors of the paper led by Steve Morley at Los Alamos National Laboratory, a very good friend of mine, where we did some of the first perturbed input ensemble modeling for ground magnetic perturbations. So to quickly put that in context, and please interrupt me if I start saying using crazy terminology with space weather, let me know, and I'll be sure to tie it back to things we understand. But in a nutshell, the currents and the electromagnetic nature of space weather can cause little perturbations of the Earth's magnetic field on the ground. So that if you had a very, very sensitive compass, it would still point north, but if you looked very closely, you'd see the needle wave just a little bit. And those little wavers, while don't seem like a lot, over a long distance can drive huge amounts of electric current through power lines and pipelines, and it's a very big problem that we're worried about in many different levels. So we did this paper to actually see, could ensemble models improve our forecasting of ground magnetic perturbations? And we found out that was the case, actually. If you just add some error bars to what you think the flow strength and the magnetic field strength are in the solar wind, and do an ensemble on that range of variables, you get quite a spread of variables perturbations on the ground, but the ensemble average was a better predictor than the deterministic model. And Sam, I think you're going to appreciate this. One of the things that the space weather community is struggling with is transitioning from a community that has been so enthralled with the science that we're now struggling to catch up on the terminology and the mathematics and the statistics behind ensemble modeling. So there's a small core of expertise that in space weather that can really take advantage of the ensemble methods that the weather folks take advantage of all the time. But I'm hoping we'll see that grow in the near future.
So Dan, I have a question because I'm not well versed with space weather much at all. So you're mentioning how you would love to get to the point to do public forecasts. Could you give some examples of what those would be and how that would help the public?
You bet. Well, there's a lot. So let's real quick, I'll rattle off the effects of space weather because it's very multifaceted. First, there's the radiation environment, right? So during a solar flare, you have an increase in high energy particles and X-rays and things like that. This can damage satellites. There was a really famous example in 2010, I want to say April 2010, that took the Galaxy 15 communication satellite completely out of commission and didn't work. So there's the immediate effects of the radiation environment on spacecraft. There is the radiation effect at high altitudes, including transpolar flights. So a huge customer of space weather forecasting products is the FAA. And not only that, it can interfere with high frequency radio systems. So this means that during periods of strong space weather, communications are strongly disrupted, and this can have effect on flights around the world. One of the effects I'm most intimate with is that of what we call geomagnetically induced currents, or GICs. This idea that the electromagnetic interaction of the Earth and its magnetic field with the solar wind can drive electric currents on the ground. And if you it's not a strong current, but if you integrate it over the length of a power transmission line, then we're talking a lot of power, a lot of DC current in systems that aren't made to handle it. The famous example is the 1989 Hydro-Quebec event. This is a big solar flare. It took the southeastern Canadian power grid offline for 8 hours, destroyed some transformers, not the small ones you see on poles, but the ones larger than a room. It can really disrupt the power grid. Boy, on top of that, it can disrupt GPS signals. It can, I'm trying to think of all the effects. What else did I miss here? So customers, FAA, power grid managers, pipeline operators, anybody who uses GPS. I know a few people. The military, especially with communications with GPS, anything precision GPS, of course, is very vulnerable as well. And I apologize to all my space weather friends out there who know I'm forgetting something right now. So what those products look like, and that's a tough question. I can tell you what it looks like now, and it's a bunch of squiggly lines. And so when I said I'm really jealous of the cone plot, I don't take that lightly. Every year at NOAA's Space Weather Workshop, a fantastic meeting that is online this April and free registration. There's always this question of how do we get the stoplight product, the red, green, the red, yellow, green, and we don't know yet. We don't know yet. It's an engineering problem because we don't understand the tolerances of different systems in this complex environment to a very complex physics system in space weather. I listen to your guys' show and I hear about the psychology of communicating these forecasts and the ways you do it. And I think, gosh, we're so far behind. How do we do that? But right now, if you look at, if you go to NOAA's, the SWPC webpage, you'll see real-time plots of the solar wind velocity, density, things like that. You'll see plots from the Space Weather Modeling Framework, both in terms of maps of what the magnetosphere looks like. So this is the region in outer space where the Earth's magnetic field is really kind of making a bubble in the solar wind. Those are, I'm going to be really blunt, those are very little forecast use to any of the customers. They don't care what the magnetosphere looks like. And then you'll see half-hour lead time forecast of geomagnetic indices like KP and things like that, that give you a very, very coarse idea of the level of disturbance of the system. Very coarse. No difference in information between Sweden and Texas. No idea. It's a semi-logarithmic scale. So going from 8 to 9, we have no idea how that translates to your power grid, to your neighborhood. We just don't know yet. NOAA's making great strides with that, trying to get maps of geoelectric disturbance with actual spatial, some spatial information there, but those are still pretty much in a testing mode. So I hope that answers your question. If not, follow up, yeah.
Thank you.
All right, Sam, I know you want to ask a question, so lead us into a discussion here before I go back to some of the basics that I need to ask.
Well, Dan, you kind of touched on it there. In the Weather Service, we have exercises with our partners, emergency managers, Homeland Security, different agencies. And they're always looking for what's the next thing I need to be ready for. And weather is always, at the top of their list, but I always bring up space weather. And we were here in Indiana in the process of planning for an exercise where space weather might lead to communication outages and logistic problems for then trying to respond. So can you talk a little bit maybe about specifically, how in a local community, let's say a big solar flare might disrupt those communications? Would cell phones be gone for a certain period of time? The power grid, I know there was in the 1800s the big flare that burned up all the telegraph wires, and just is that a reality for us soon? Kind of what's your maybe worst case scenario, or what keeps you up at night with regards to that, and what emergency managers might have to worry about in the future?
Well, to be to be perfectly honest, what keeps me up at night is not knowing if our models are good enough to say what the worst case scenario is. And that's right now I know there's somebody out there on the development team thinking, oh, don't say that, dummy, our model's great. But that's the truth of it. I don't want to say we're overdue for another Carrington event. But I think that we're very vulnerable, and there have been a lot of strides made to improve the robustness of different systems between 1989 and today, especially with the power grid. But we're tremendously vulnerable. Let's worst case it for a little bit now. The event that you referred to in the 1800s, the famous Carrington event, fantastic reading for everybody out there. A solar flare so big it could be seen with the naked eye, huge sunspots associated with it. If that happened today, the estimates are that we would be without power for months. And from the power grid point of view, the issue is that the systems that really take a lot of the brunt of the damage are these large step up and step down transformers. These are made to order, they're custom made, they take months to produce. There's very little, if any, stockpile. It represents a huge vulnerability. So what happens is that if you lose 5, 10, 15 of these across a large section of the power grid, you're done, right? And so you talk about cell phones. When do the cell phones go out? The cell phones go out when everything runs out of power. You can't charge your battery. You're having a hard time fueling your generator, and the network of the cell towers that keeps things going together is just not maintaining. Not able.
Hey,
to
Dan,
maintain
what extent are you talking about power outages here? Are you talking about North America, globally? What's the extent?
You're definitely looking at a continental scale. So the 1989 Hydro-Quebec event was, I think, 1 or 2 transformers. I think just 1. That was Toronto. That was the Eastern Canadian power grid down for 8 hours. That was 1. That was a strong storm, but that was nothing like a Carrington event. It would, I think, well, let me put it like this. I think the easiest way to describe it is to describe a presentation I saw by a reinsurance company at the Space Weather Workshop. So this is a company whose job it is to insure the insurance companies. And they were showing their estimates of what a Carrington event today would look like in terms of loss. And I think they were estimating like a 5% loss of transformers across the US. And they were saying, yeah, this is basically going to be a 2 to 3 month without power across the continental US. The extent of something like a Carrington event is definitely easily able to take out power across Europe or Asia or the United States, if not all 3. But it's really dependent on some things that we don't understand yet, like how localized these effects could be. If for a Carrington-like event, well, for a typical event, we expect strong effects on the night side, just because the way the physics work. During periods called substorms, which are small events that cause beautiful, beautiful aurora. A Carrington event has the capability to move the auroral oval down over the central United States, if not lower. It pushes the effects of space, the strongest electromagnetic effects of space weather, over regions that are far less likely to be prepared compared to Northern Europe, where they are focusing on this kind of thing all the time. And it has easily the capability to cause, instead of localized aurora, large swaths of aurora across the whole United States. Aurora is a lot like a fluorescent light bulb. So you're looking at electric currents. And now you think about a current flowing across the whole United States and what that's going to do to the power grid. It's just going to be a huge inductive event and able to take out affect large areas of the planet at once. So
so give us a probabilistic outlook. That's what we do here. Give us a probabilistic outlook on a Carrington event in the next 20 years. In the next 20 years.
Well, we had a near miss in 2012.
Oh boy.
It's really hard to say. I think a Carrington is probably more rare than a 1 in 100 year event. I'll say that. A 1 in a 100 year event is still going to be very, very bad. It's going to look at least as bad as the 1989 event in Hydro-Quebec. So once in 500 years, once in 200 years, we actually don't know. Will we see one in our lifetime? I would say 5% chance we see that, but that's completely subjective, completely subjective. But we did have a near miss in 2012. There's a couple of really good papers using the space weather modeling framework where they said, what if that event hit Earth because it hit a satellite out of the Earth-Sun line, one of the stereo spacecraft. So they just took those observations and put it towards the Earth. And that one was in July 2012, wasn't quite Carrington class, but it was probably going to give us a bad day. Something more typical that you see is, excuse me for being very forgetful. Was it 2018? We had the series of hurricanes that hit oh my gosh.
Puerto Rico?
Puerto Rico. Thank you so much. In 2018, those coincided with a series of space weather events, not the kind that make the news, not the kind that give us really strong aurora even over Michigan, but the kind that exacerbated the humanitarian crisis in Puerto Rico because it interfered with the high frequency radio communications and made the deployment of aid and recovery efforts more difficult. And I'll have to find, there's a paper on that in the Space Weather Journal I'll throw your guys' way, talking about how space weather affected the hurricane recovery efforts down there. So I mean, on a more typical 1 every 1 in 5, 1 in 3 year scale, space weather is a force multiplier for extreme terrestrial weather. It makes using our technological systems to recover from those events harder. On a 1 in 100 year kind of level, you're kind of reviewing your apocalypse training where it can get pretty ugly.
And we just had some practice with that in Texas, and it didn't go well, and it was just for a few days.
Yeah, that was no fun.
But I gotta ask a question real quick, Bill. I'm sorry. I'm
no.
hogging
That's
the
what
show
we're here
here.
for. No, that's what you're
So
here for.
so you got
you're
some
the
old ham
boss
radio.
hog.
No, you got some old ham radio guys here.
Yeah.
Oh, of course.
So,
You guys love
so
space
we
weather.
work HF. I mean, we're on 80 meters and 40 meters and 20 and 15 and 10. Are you going to offer like propagation forecasts for us? I mean, it sounds like you're kind of going down that path.
Me personally, no, but that definitely happens, right? The ham radio folks, I'm not a ham radio person, so I will speak very ignorantly here, but My understanding is that the conditions that arise during space weather events allow you to broadcast and receive over much greater ranges, because it allows you, basically the conductance in the ionosphere, especially on the night side, increases, and so you get a Earth atmosphere waveguide that helps your signal propagate. So you actually, I think during strong space weather, you guys are very excited, right?
Yeah, it's rocking and rolling. Yeah,
Yeah.
when the sunspot cycle just goes away, it's dead. I mean, 10, 15 meters dead. But you give us some good action, and it gets really interesting, all the way up to 6 meters, which is 50 megahertz. So
Well, my
we
apologies
we
for the
we,
weak
we
solar cycle.
yeah, yeah. But we pay very close attention to all the ham radio. In fact, Jay Farlow, who's our friend, asked this question, and I think it's fascinating. The correlation between space weather and propagation characteristics, and that affected, you're right, the Puerto Rico communications. And I understand it's a big deal, one way or the other. And so this whole thing is very, very interesting to me, because it affects all of us, and people don't think about it very much.
I didn't think about it at all until I got caught up in the research of it, and then you start explaining it to people, and one day it hits you. Yeah, this is a problem, isn't it? So
So Sam said the key word here, the things that keep us up at night. We talked to Dr. Neil Jacobs last week and mentioned some of those. And now this obviously is something that needs to be on all of our radars. James, I think we're going to have to call this like weather doom brains or something from now on. But I think it's really critical. So how are we coming in the mitigation processes? Are the upper levels of government paying attention to this, or the power grid systems paying attention to it? Because I think it's really important.
the amount of attention space weather has received over the last decade has increased year after year after year. So that's really the good news, is that we know it's a problem, and there are many agencies taking action. I actually, doing a little homework for the show, I pulled out my copy of the Pro-SWIFT Act. So this was a law passed last year in October that was the culmination of a lot of work in many different government levels. But essentially, in 2015, the National Science and NSTC, National Science and Technology Council, created two documents: the National Space Weather Action Plan and Space Weather Strategy. So these were fundamental guiding documents trying to talk about ideas of what agencies should be doing what things in terms of space weather, who should be in charge of forecasting and operations, what's the role between NASA and NOAA, and how should they be delegating tasks spanning from fundamental research to incorporating and bringing the private sector on board. What should we be doing in terms of paying attention to space weather benchmarks, not only for forecasting, but also for resilience. That was turned into a bill that was passed last year, Pro-SWIFT, which, I got to remember what it stands for. I'm so sorry. The Promoting Research and Observations of Space Weather to Improve the Forecasting of Tomorrow Act, or Pro-SWIFT Act. So this now law does a couple of things. It's going to create several committees based, drawing on people from NASA, NOAA, National Science Foundation, Department of Defense, and the Department of the Interior, including the USGS, the United States Geological Survey. It tells that council how they should be and will actually engage with academia, with the private sector, with non-governmental customers and users of space weather data. It discusses how benchmarks are going to be reviewed, identified, and implemented every year. What I really love about the document is how it really is doing a lot of work to make sure everything is science-based and science-governed. Since the Obama administration, space weather has been a White House issue, with the administration's receiving daily space weather briefs as part of their daily briefs. So space weather is every day up there, which is fantastic. And that wasn't the case before. In I want to say 2017, but don't quote me. I was at the Space Weather Workshop conference in Boulder, Colorado, and we had a remote talk, which now sounds mundane, but back then it was cool. A remote talk from the White House Situation Room. How cool is that? How cool is that? That, you know, the White House has a plan for acting on space weather, and ProSwift really formalizes a lot of that. On top of that, the FAA is incredibly active in being a part of these conversations. The major power regulatory bodies, NERC and FERC, have been establishing new guidelines for making sure the power grid is resilient to the effects of space weather, and that's been an active and ongoing project on their behalf. I had a really funny conversation with somebody. You know, one of the reasons you guys called me up is because of my recent paper in space weather about a potential worst case scenario storm and some simulations for that. And one of the gentlemen who works with FERC on this, a scientist, said, "I'm really glad your paper came out after we came up with our first set of guidelines, because some of those numbers got scary." And on top of that, we see a tremendous increase in the amount of funding specifically for space weather. Space weather, I'll be really honest with you guys from a scientific point of view. Space weather, for the earliest parts of my career, used to be the buzzword that people put in there in their proposals, so that someone at NSF or NASA could be like, "Oh, and there's your broader impacts. We can check that off. They get a good score." The paradigm shift has been fundamental in the last 5 years, where there is funding from NASA for O2R, operations to research, specifically how on the proposal you have to have somebody from operations as part of your team. You have to identify what products you're going to develop from research to operations. We had a really very cool development in 2015 and 16 when the NSF pre-events proposal call came out. Pre-events it's one of those long acronyms, but it's essentially a pool of money for extreme event, natural disaster event resilience and risk mitigation. And space weather was right up there next to earthquakes, hurricanes, tornadoes, everything. And there it was. And you know, we were able to pull in a lot of research money to advance our models under that funding opportunity. In fact, we have been undertaking with our continued work with the people at Michigan, taking the SWMF and for the first time trying to include the effects of ground conductivity. Well, that sounds crazy, right? But it turns out, like, if you're trying to induce currents on the surface of the earth, some of that's going to go through your pipelines and power lines, but some of that's going to go through your rocks. So you have to know what's in the ground below you. So now we're talking about teams of geologists, forecasters, space weather modelers, all working together to bring these models together. And for the first time, these kinds of proposals are really attractive to these agencies because we see these types of funding opportunities being available. Oh boy, there's a lot of stuff going on with space weather. But that kind of, hopefully that gives you a good idea of the kinds of things that are happening at the large scale, at the federal level and things like that. It's a really exciting place to be right now.
So Dan, talk for a minute, because you referred to, sunspots and I guess what we're talking about on a lot of these things, because we did want you to come tonight to talk about this perfect coronal mass ejection, and I don't imagine that's a good term. It's more like Sebastian Junger's perfect storm than a good thing. But talk for a minute about what happens in a solar minimum, and are there any real ties to climate based on that? Nate, you can smack me if I get off into some weird world here, but You know, are there any ties there? And then to add to our list of things that keep me up at night, what about the magnetic reversal? Is that a real concern? So address,
Oh,
kind of talk through that, but don't let me forget to
yeah,
get you to weigh in on the magnetic reversal thing.
you bet. You bet. Well, let's start with boy, a lot of topics there. I'm so sorry. Let's talk about the solar. Let's talk about the solar cycle really quick. And I apologize if I missed too much of some of the background information, but
Mm-mm.
essentially the sun has a magnetic cycle with a 22-year period where essentially the sun's magnetic field flips in polarity every 11 years. So after 22 years, it's back roughly where it was 22 years earlier. But it's a very chaotic and messy process, such that you go from something that looks kind of organized to something that looks like just somebody is holding onto a Van de Graaff generator, and lines and magnetic field traces are going in every direction. At the foot point of bundles of really strong magnetic field lines are sunspots. These are really hot, active regions with strong magnetic fields, and they come in pairs. Uh, and those guys can become unstable, right? And so you can get these bursts of energy from these sunspots, and that's where solar flares come into play. Those are bursts of X-rays and relativistic particles that move through space. And then, and these are the really cool things, you can get these events called coronal mass ejections. So at these active regions where you have these strong sunspots that are the foot points of tremendously strong magnetic fields, suddenly that whole system becomes unstable. And just go on YouTube and Google coronal mass ejection footage, because the satellite imagery of these is just amazing. But you'll see these lines, these glowing lines that are, it's the plasma, the hydrogen and the electron, the protons and the electrons bound to these field lines, glowing, suddenly twist up and blow off. And you can almost hear the sun go, and this little puff that comes off is the equivalent of taking Mount Everest and vaporizing it and letting it blow off into space. And so that's the solar tsunami. That's the big event that carries with it a lot of energy and mass too, right? Just a lot of gas moving and a lot of magnetic field moving through the solar system. And it comes and it hits the Earth's magnetic field, or if you're Venus or another planet like that, it hits your atmosphere and blows off some of the atmosphere as it moves by and drives aurora. Those types of events are far more common during solar maximum, when the sun's magnetic field is complicated and chaotic and energy is just stored in these magnetic fields waiting to be released impulsively. You do see activity, other types of activity. We have what we call high-speed streams, where the sun is really complicated. The reason I study the Earth is because the sun is my favorite black box input, right? It's just tell me what the sun's doing. I can't dip into it. It's too much for me. But in a high-speed stream, you have a region of slow solar wind and a region next to it of fast solar wind. And the sun is spinning 27-day period really fast. So think about it like a sprinkler in the yard, right? And this slow solar wind goes up first, and then this fast solar wind comes up behind it and pushes it and compresses it and makes a shock wave. And so these won't be really big events. These aren't going to be the ones that keep us up at night, but they're going to be a nice solid energy input to the system. So we're always trying to figure out what's the biggest coronal mass ejection you can get, how fast is it going to be, how much mass it's going to carry with it, and what kind of magnetic fields is it going to carry with it. And that kind of leads to this idea of the perfect CME. But before I get there, let's real quick talk about space weather and climate. Now, I want to emphasize I know enough to be dangerous, so don't take my word for it, but I'll do my best to explain what I know. The sun's output is not constant. and it varies with the solar cycle. And you do see this on climate. You see that's one of the things baked into climate is the varying output of the sun. So I think it's natural to think, okay, one of the inputs we have to think about when we're studying the climate and understanding climate change is the variability of the sun, right? And climate scientists do. But I get email, as we all do, and I often get email about, well, don't you think all of this global warming is just because of the sun? And the first thing you should do is turn and point out that the sun over the last 15 years has been very quiet compared to the previous 100. And so global warming is actually happening in spite of all that. I know that the European Union commissioned a research team to try to better understand the connection between space weather and climate, and they saw no significant connection. And I did see a fun talk from a gentleman from Columbia University at Space Weather Workshop. I have to admit, I'm on the organizing committee for Space Weather Workshop, so I'm going to continue to plug that all night. It's a great workshop. But he talked about this as well and pointed out that in their numerical modeling efforts, they had a really hard time finding any correlation, any meaningful correlation between space weather and climate change. Now, that said, the takeaway here is that, of course, the sun is one of the most important drivers of climate, and the sun has been putting out lower than usual energy over the past decade plus. So yeah, I hope that helps answer that.
It does. And I'm learning so much tonight, James. This is some pretty incredible information. Talk about the relationship between, if you can, Dan, the cosmic rays and clouds.
Oh no, I can't. I'm so sorry. I know there is one.
So there is some relationship there. And do we have more cosmic rays when we're having a solar maximum or a solar minimum?
Surprisingly, we have more during a solar minimum. So what you will get more cloud cover. Oh, excuse me. You're going to get more cosmic rays during solar minimum because what happens is this effect called Forbush decreases, where the effect of fast and strong solar wind is that, and especially from coronal mass ejections, is that the cosmic rays coming in from outside our solar system are more likely to be deflected at the edge of our solar system or cleared out by a coronal mass ejection moving through the solar system. So that is there is a connection there. I do know there is a connection between cosmic rays and cloud seeding, but this is where I know that some of my professors back from my early days of grad school are going to be disappointed in me. So I'll let you guys talk more about that.
You can't remember everything. So talk about the magnetic reversal here on Earth. Is that something really to fear, or what will be the impact?
That's a really good question, because I don't think we know. It's so the background information, right, is that the Earth's dipole field, it's more, multipole, it's really complicated, but dipole's good enough for government work. It is not constant. And in fact, we do see it move today, right? We'll see it kind of slowly drift over many years, and sometimes it'll kind of move quickly before slowing down again. And we do know from the geologic record that at some point our magnetic field is going to reverse. And we're not sure what that's going to look like yet. Is that going to be a fast flip? Is it going to be something like we see with the sun, where our field becomes more complicated and then kind of rebuilds itself over a period until it's reversed? We don't know yet. One of the most fun things we do is numerical modelers is just turn on all the switches in our code and play with things. And one of the things we like to look at is what happens if the magnetic field was sideways? I have to plug some very early work by my grad student, Agnet Mukhopadhyay. He's a brilliant scientist. He's going to have a first author science or nature paper coming up. That kid is amazing, and I look up to him in so many ways. He decided to start out of nowhere, just decided to start working with some geologist in Germany to say, what would the magnetosphere look like? What would space and Earth look like if the Earth's magnetic field was tilted on its side? And he's basically finding like the auroral oval, which normally encompasses the North and South Pole, would be like centered over the day side of the Earth and the night side of the Earth, and all these crazy features. He's created some very first look numerical approximations of where the aurora would be in this crazy situation. So look forward to that work. That's on the horizon in terms of the science of space weather. But in terms of what it means for life on Earth, I'm going to give you a very honest I don't know. Because people often say that you hear people talk about the Earth's magnetic field as a shield against the effects of space. And that's very only partially true. The highest energy particles, the highest energy radiation in space, cuts through the magnetic field like it's not there, and it is our atmosphere that's doing the bulk of the work, stopping it. A lot of the other, the energy that the atmosphere, excuse me, that the magnetic field really shields from the atmosphere, if we didn't have that magnetic field, what would happen? Well, we would look a lot like Venus, where the solar wind comes in and the only thing that stops it is the very top layer of the atmosphere of Venus. And the flow strips off particles from the top layer of Venus's atmosphere. And I think if I looked up some numbers in literature right now, the number I would find is 1 × 10 to the 26th particles per second being lost from that atmosphere. And I believe that number is in the ballpark for Mars as well. Now, funny story. You have the Earth's magnetic field. The solar wind comes in, presses up against it. That magnetic field buffets that energy and transmits it down into the North and South Pole of the Earth, where it's funneled into the atmosphere, where you get currents flowing through the top layer of the atmosphere. And particles are energized. Particles are ionized. They begin to flow out in what we call the polar wind. And we start to lose 1 × 10 to the 26th particles per second from the North and South Pole. Now, that number sounds really familiar, doesn't it? Now, I have to be very, very careful here and emphasize that this is an open question in space physics right now. To what extent does our magnetic field protect our atmosphere, or does it just redirect that energy to the poles? And we don't know, and we're exploring other planets to better understand this. There are several science centers around the US focused on this problem, the role of a magnetic field in determining the habitability of a planet. So Bill, to answer your excellent question, I love that question so much, I'm glad you asked it. I don't know, and I don't think many people do know how much we have to fear a magnetic reversal. I think in terms of, I can tell you, it is far more likely we're going to see some Carrington events before we see the Earth's magnetic field flip. So James, I can give you that probability at least, right? That
Yeah,
we
good.
Yeah, one big event we don't have to worry about quite yet.
Yeah, I was just seeing in the news all this past week about this space hurricane, and it was quite fascinating. I'm a little bit of a weather and a space nerd, but I had never heard about this. So can you talk a little bit about, what that was and how it confirmed the theories that were out there?
Oh, that's one that's going to catch me off guard.
That's what we do on this show.
You guys are good. Yeah.
Yeah.
I remember, a couple episodes ago, Dr. Uccellini talking about how he felt like being on the show was going through his PhD defense again. And
He compared it to a congressional investigation.
Yeah.
so, Sam, no, I did see that news release. And I remember looking at the picture. I didn't read the article. I'm so ashamed to admit that now. And I remember seeing the nice flashy graphic that went with it, and I said, "Oh, I wonder if they're talking about upper atmosphere ionospheric vortices that you see." But I didn't read the article, so I don't want to guess too much there. I'm so sorry.
No, that's fine. It was just such an interesting story, and it just shows where space weather, how little we know, but yet, as you mentioned, the potential dangers out there and the unknown is very scary. So I appreciate your honesty. I'm looking forward to reading more about it myself, actually.
Hey, Dan, tell us about the Space Weather Prediction Center within NOAA. That's kind of a mysterious organization. Where is it physically located? How many people work there? What's the objectives?
Oh boy, a lot of good questions there. It's in Boulder, Colorado, at NOAA's facility there. It is, I don't know actually how many people work there. I'm so sorry. I would say probably on the order of a few dozen. But I could recommend some really good guests for you guys from there that would just be brilliant to talk to. People I'm very proud to work with, honestly, and have worked with in the past. They are in charge of predicting space weather, just as the name says, right? Being the arm of NOAA to provide forecast and products about space weather to the general public, but more importantly, because of the nature of space weather, to critical end users of that information. The power grid, the FAA, who else am I missing? They work hand in hand with the Department of Defense, the Air Force, and the Navy, especially. So their goals and their work has changed quite a bit over the last couple of decades, from being an arm that was really more about the science of space weather to, over the past decade, really taking on the weather forecasting angle. One of the people who I've been very proud to work with is Dr. Michelle Cash there, who has worked hard with the others to formalize the way in which they take scientific numerical models and turn them into operationally viable models. Because just 10 years ago, SWPC had just a handful of experiences with that and didn't have a real formalized process. And Michelle and others working there have really worked hard to turn that into a process so they could turn that over faster. It's a really cool facility. I went on a tour when I went to visit, and it's very space agey with all the televisions on the wall, and the lights are down low, and everybody working on at their terminals there. It's not a terribly big room at the forecast center, but it's active, and they have people on call there 24/7. They put out space weather forecasts via email and other communication products regularly. You can get it. Anyone can sign up for it. If you go to swpc.noaa.gov, you can sign up for their products and see what the chances are. They put out probabilistic forecast of space weather activity and on different time scales to the best of their ability, and they do a great job at it.
So in the weather enterprise, we have learned that we have to work with social scientists. Our
Yes.
background is physical science. We don't know anything about communication, human behavior. We really don't. And that's been a marvelous thing for us. Is there any effort on your end to do something like this? Because I'll be honest with you, we probably have some people after listening to you tonight that want to dig a hole or go live in a cave. I mean,
me included.
Yeah. So do you incorporate social science at all? And again, people will have phobia. I mean, people have fear of thunderstorms. People have a real fear of tornadoes and hurricanes. I mean, they're scared to death. And in our messaging, we have to be cognizant of that and do it in a way that's not going to get them whipped into a further frenzy. So do you work at all with social scientists on this?
Not yet. And I have to credit y'all's podcast for helping raise my awareness of just how important that is. And I'll tell you why. Because the critical customers are still industry and military and governmental, we haven't had to be aware of the social messaging at that level yet. And I think the problem with space weather is that if I told everybody that we were going to see a GIC event in this region at this time, it's not quite like a hurricane. The extent to, you don't need to board up windows. You don't need to go into a basement or a shelter. You just have to hope the power grid doesn't go down. So perhaps you prepare ahead of time in terms of supplies and radios and charging your batteries and things like that. But it's not like a hailstorm or something like that. So we as a community, we haven't had to be aware of those things yet. We do need to start thinking about the messaging of our science and our understanding of space weather. And again, to be brutally honest, this is something I've come to realize this week, where for the first time in my life, I saw my research on somebody else's YouTube channel with scare music put on it. And I'm just looking at that video thinking, it was a hypothetical. So I think where everybody in the general public needs to be with space weather right now, mentally, is a space where you should watch the forecast of space weather with the hopes that you're going to see the aurora, because that is the most likely outcome of any given space weather event.
And I'm glad you said that, because here's my next question. A lot of photography dweebs listen to this show, and they really, really want to get themselves in a prime position to capture that magical aurora display. What are some practical tips for photographers and maybe just people that would just love to see a display once in their life that live in the lower latitudes? Give us some good practical tips, data sources. What do you look for? What sites do you go to? What do you do?
Well, I'm going to plug one of my favorite projects, aurorasaurus.com. It is a social network where you report if you can see the aurora right now to their website, and the website also works on trying to understand if, when people refer to the aurora on social media, if that constitutes a real observation now. You can get alerts on your phone if there's aurora in your area. When I still lived in Michigan, I got an Aurorasaurus alert, and I woke up at 2 a.m. and I ran outside, and I was in Ann Arbor, Michigan, so I couldn't see anything. So I got in my car and I drove down I-94, and I did see something. But other than that, let's see here. Data sources, look for any forecast of the position of the auroral oval. The auroral oval is not a fixed circle, but it grows and moves down in latitude as space weather activity intensifies. It's a very, kind of conceptually strange thing to think about, but just think about this oval that just gets wider and can cover a bigger circumference, and so it can move down to lower latitudes as space weather picks up. Obviously, you want to be on the night side so you can see it. If you are dead set on seeing beautiful aurora, you're going to need to travel to Alaska. You're probably going to want to travel to somewhere in Scandinavia. That's where you're most likely going to see it. and it happens all the time. I mean, if you have a week-long trip in one of those places in the winter, I'm not saying 100% you're going to see it, but there's a really good chance you're going to see good aurora.
But let's say you're in Miami. Let's say you're in Miami.
You do
you've got
not
a
want to
budget.
see aurora in Miami.
But I'm saying,
We're
let's
in
say
big trouble if you do.
you got a travel budget and you're willing to spend some good money on a plane ticket to Alaska or Scandinavia, the northern latitudes. How many days in advance do you have an idea of when you might catch a really good display?
Not much. And here's the problem. The system is strongly driven. There's not a ton of inertia in space weather like there is in terrestrial weather. So basically, if you had your finger on the book flight button on the website, you're basically starting with observations of the solar atmosphere and looking for a coronal mass ejection to light off. You then have probably 36 hours to get where you think there's going to be aurora. While you're in transit, you are looking at a data type called a coronagraph. So this is a picture of space aiming at the sun, and they have a disk covering the sun, and you can see the coronal mass ejections puffing out from the side. You're going to look for a halo CME. That's a CME that's heading directly at you, so it looks like a halo around the sun growing and coming at you. 36 hours is the typical travel time. The last 30 minutes, you are looking at in situ observations of the sun's magnetic field. And you look at the Z component on NOAA's website, and if it's negative or southward, then in probably anywhere from a half hour to 45 minutes, you're going to see aurora if you're in high latitudes.
So let's say you've got Bill and me and Nate. We're down here in these low latitudes. What's a record display, lowest latitude, far south?
Boy, that's a good question.
In your lifetime, just out of curiosity. Dallas, Fort Worth, Atlanta, Nashville, Little Rock, Phoenix. Any hope of ever seeing a display this far south?
Yeah, you ruined my you ruined it when you included my lifetime. The Carrington event pushed it down to Florida and the Caribbean islands. You don't want to see the aurora in Little Rock or Texas or Florida. For every moment you're like, wow, this sure is pretty, you're going to be thinking, boy, I wonder what New Earth is going to be like. So it's just, that's seeing it that low, 1 in 100 years. Seeing it in lower Michigan, I saw red aurora just outside Ann Arbor, Michigan in 2003 in one of the most strong events that hit the Earth in the last 20 years. How low did it get for the 89 storm? I would say upper third of the United States is probably a 1 in 25 year kind of event.
Okay. So one more question. We have to take a break in just a second. In the weather business, we have watches and warnings prior to high impact events, tornadoes, flash floods, severe thunderstorms, hurricanes. Do you have anything like that in space weather when it comes to a major geomagnetic storm?
The only thing there is the NOAA scales for space weather activity, G1, G2, G3, G4, G5. NOAA will issue warnings. I don't know to what extent that they follow the typical watch and warning level that you'll see with a hurricane or a tornado. So that's a good question, the degree to which those two match. But when NOAA issues a space weather warning via email, I think the format looks more like you'd see on a raw weather feed for warnings, but it's not. I always think I'm rather naive when you say tornado warning and tornado watch. I think about that little icon in the upper left hand of my screen from when I was a kid. So nothing quite like that yet. Nothing quite. We don't have the red, yellow, green stoplight signal yet.
Awesome. All right. Well, we're going to take a break right here. And we do want to thank the AMS Weather Band for being a partner with the show for the next few weeks. We're going to take a break, and we will warn Sam and Dan, we're going to need a pick of the week here in a few minutes. So be thinking of something related to what we're talking about tonight, weather, space weather, anything like that. So, but let's take a quick break. We're going to come back with Jen and This Week in Tornado History. We have Tony Rice, his astronomy report. We'll have the weather roundup, picks of the week, and much more as WeatherBrains rolls along.
Calling all weather enthusiasts. Join the American Meteorological Society by becoming a member of the band at amsweatherband.org. As an AMS Weatherband member, you'll get to go behind the scenes with the scientists of the American Meteorological Society, whose members have been at the forefront of weather, water, and climate research for over 100 years. You'll learn about the very latest research from the scientists who are actually doing it. What's more, you'll become a part of a passionate online community of weather enthusiasts. Get access to exclusive videos, webinars, and other fun content, and support the science you love. Learn more and join the band today at amsweatherband.org.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
Next Sunday, March 14th, or 314, is Pi Day, a nerdy celebration of the number which describes the ratio of a circle's circumference to its diameter. The day was recognized by Congress back in 2009 and has also been recognized by the United Nations. We couldn't explore space without pi, in large part because getting from point A to point B involves a lot more curves than straight lines, because, well, gravity. The engineers building spacecraft make a lot of use of the number as well in their calculations of things like fuel tanks, which, unlike the boxy one in your car, are usually spherically shaped, and this is to accommodate high fuel pressures while reducing weight. 3.14 is good enough for most applications, and you might even go out to 3.1459. But as an irrational number, the digits just keep going and going and going without repeating. So the question is, how much pi does anyone need? How much pi is enough? A few years back, a Google engineer calculated pi out to more than 31 trillion digits. It also required 25 virtual machines running in the cloud for 4 months straight. Not even NASA needs this much precision to navigate not just the solar system, but beyond. The Jet Propulsion Laboratory routinely uses a 15 decimal place approximation of pi. It may not seem like a whole lot, but consider this. The Voyager 1 spacecraft is more than 14.1 billion miles away. Using that same 15 decimal place approximation, we can calculate the circumference of a circle with a 14.1 billion mile radius to an accuracy within less than 2 inches. That same version of pi will also give you the circumference of Earth, not just within the width of a human hair, but a 10,000th the width of a human hair. Still need more digits? A 40 decimal place version of pi will give you the area of the 93 billion light year across visible universe within an area the size of a hydrogen atom. So yeah, 3.14 is probably good enough for most applications. Elsewhere in the sky, look for Saturn and a sliver of waning crescent moon low on the southeastern horizon before dawn on Tuesday. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, an isolated supercell developed just northwest of Atlanta, Georgia during the evening of March 14th, 2008. As the storm moved into the city, it produced a tornado that caused damage on a 6.25-mile path from west of the World Congress Center in Fulton County to the south of I-20 into Cobb County. Maximum winds were estimated at 130 miles per hour. The tornado developed near the intersection of Simpson and Burbank Streets in the Vine City neighborhood, just west of downtown Atlanta. It moved over the middle of the Georgia World Congress Center and about 100 yards north of the Georgia Dome. The tornado struck during an NCAA basketball game between the University of Alabama and Mississippi State University. The storm hit at 9:38 p.m. Eastern Daylight Time, and the game was in overtime. Had it ended after regulation, thousands of people would have been in the streets heading home. The tornado left the Georgia Dome and moved across the CNN Omni Hotel complex and Phillips Arena, where an NBA game was ongoing. It moved over Equitable Bank Tower, across the Interstate 75-85 downtown connector and the Edgewood exit, and then into the Cotton Mill Lofts across Oakland Cemetery. The tornado weakened and then lifted in western DeKalb County. Approximately 50 homes were damaged. Several multi-story towers and commercial buildings near and east of Centennial Olympic Park also sustained damage. Windows were blown out of several of these buildings. There was one fatality. It occurred in a parking lot across Decatur Street near the Martin Luther King Jr. MARTA station. A brick and stucco wall collapsed the victim. Some of the most significant damage was at the cotton mill lofts. The roof was blown off and exterior walls on the top or fourth floors were blown inward. 2 sections of the 4th floor collapsed all the way into the basement of the building, trapping several people. Read our summary of this event and hundreds more on our website, tornadotalk.com.
Jen, you always pick the most timely events. James, we remember that event well, don't we?
Golly, I could tell a story about that deal, Jen. I had been out, and I don't want to take too much time here, but in the break in the newscast, I went out to throw some batting practice to our son, who at the time was 9 years old. Came back, I walked in and my phone rang, and it was the producer of the University of Alabama Sports Networks. And he said, I don't know what's going on here. This got to be something weather related, because there's tiles falling from the ceiling. This place is shaking. We don't know. Nobody's saying a word. And so I went on the air with him. I looked at the radar, and it was horrifying, just horrifying. The signature going right through downtown Atlanta. And so I stayed on the air with those guys doing wall-to-wall weather for 15 minutes on the University of Alabama Basketball Network. And I think that event took the Southeastern Conference from worst to first when it comes to weather awareness. They didn't tell anybody. The coaches didn't know. The fans didn't. Nobody knew anything. Where now it's just the opposite. They are really good at informing people at all of their venues whenever there's a tornado warning or a thunderstorm or lightning, and they've got a good plan. So anyway, I could talk about that night for a long night, but that was a very interesting night.
It sure was. And of course, the main component of all of our warning systems is NOAA Weather Radio. And Bruce Jones, we're really thrilled to have him each week from Midland to come on and talk about this very important subject as the unofficial, but in our book, official ambassador of Weather Radio. Bruce, how are you tonight?
I'm very good. Thank you very much, Bill. Good to see you all. And yeah, you know, I have always advocated that people should have multiple and redundant ways of getting these warnings. And we've never lived in an era where there were as many ways to disseminate the warnings. And so it's always shocking and a little bit heartbreaking to hear that someone didn't get it or didn't know that severe weather was imminent. But, you know, I know we can all get busy doing other things. So I encourage all of you who are WeatherBrains fans that watch or listen to this podcast to just make sure that you're one of the people who's spreading this message that folks need to have multiple and redundant ways of getting these alerts. And your cell phone is great. Your, sign up for apps, and your county emergency manager may be able to send out phone alerts. There's Weather Call and other services like that. But don't forget about good old fashioned, reliable, proven NOAA Weather Radio, because it's a radio frequency broadcast, and it really does work very, very well and very reliably. As soon as the radar operator at your local National Weather Service office pushes tornado warning for that polygonal area on that map, the NOAA weather radios in that county are going off within maybe 2 seconds. It's really, really fast. And it's loud enough that everybody in your house can hear it, because that's what it was designed to do, to be an indoor tornado siren. And these things, you can get a desktop weather radio for about $30 or $35. And you probably spend that more on Starbucks lattes in a 6-month time period. I know my teenagers do. So, just put it in perspective. It's not very much money to save your life. And so I ask and I beg those of you who watch and listen to this podcast, please be part of spreading this message that everyone needs to have multiple and redundant ways of getting weather information. Here's our special for WeatherBrains fans. The promo code is SPANN, SPANN 25. That's SPAN 25 is the promo code. When you go to midlandusa.com, you can use that promo code to get 25% off all the weather products and the accessories. So, we're just one company, one manufacturer of these things. And this is the company I work for, and we've got this special offer for you. But please, for crying out loud, no matter what brand of weather radio you buy, make sure you have one in your home, because America has the craziest, wildest weather on the planet. And we as citizens of this country, it's imperative that we be prepared for this stuff, because we're getting into the season right now. So the promo code is SPANN25, SPANN25 at midlandusa.com, and that'll get you 25% off of your weather radio purchase. So that's
I've got to add, Bruce, I think the most important thing you've said is that we're asking the people that watch and listen to be ambassadors. There's a good chance you might have a weather radio, but we're coming up on the core of the tornado season here between now and summer. It'll gradually move north with time. And every year we have tragic loss of life. And most of the time that loss of life involves people not getting the warning. And if every home in this country, every business in this country had one of these boxes, the death toll, we can't reduce all the loss of life. We know that, but boy, it would be greatly reduced. And these are precious people every year that lose their life to tornadoes and other weather hazards. So if you have one, and if you're on board, and if you're a weather dweeb or geek or nerd or dork, do us a favor and be an ambassador. That's the greatest thing you can do, is to, tell your friends and neighbors about this offer and get them in on it, because it's very important. It is so frustrating, Bruce, where I see everybody's got a smoke alarm. Everybody, it's the law, but goodness, the weather radio penetration percentage is not where it needs to be. So now's the time to do something about it.
Thank you. Very well said, James. And I appreciate that support. And you're right. We need to get everybody who's listening to be ambassadors and spread that word. So thank you, sir.
Awesome. All right.
Thank you.
So
now, where you want to go now, James? You want to talk to Sam for a minute, or you want to go into the weather roundup?
Yeah, let's talk with Sam for a minute, because we need to talk about Indiana.
Yeah. So we talked about this little basketball tournament coming up. It was the SEC, was the weather story tonight, some 13 years ago. But, the SEC tournament's coming this week. And then the following week, we're going to all be in Indianapolis. So Sam, talk about the support for that event that your office is having to provide. I imagine that's pretty significant, because you're going to be increasingly into thunderstorm and tornado season there, I guess, by the time that kicks off.
Yeah, absolutely. And with the La Nina that's going on, active severe weather potential across the central United States here in March into April. So yeah, we're very aware of that. We've already been in communication with a lot of the players that are involved, and we'll be working with emergency managers, making sure everybody's aware of how to get our information, providing those decision support services as they're needed. And, even with reduced crowds this year, I think they're talking 25%. That's still several thousand people in the downtown area. So, fortunately, we had a good run through in previous years with the Final Four in Indianapolis, and when the Super Bowl was in Indianapolis. So there's great plans in place, and we're just going to continue to build off that and work on that. And hopefully we'll have a stretch of weather like we've had here to start March. No precipitation, first time ever this far into March without precipitation. We came in like a lamb, and we know what that means going out of March. So a little concerned here for that.
Yeah, well, let's don't have that. But talk about the symposium for a moment. It's coming up real quickly, and talk about its format, how people can register, some of the speakers, and the agenda. So.
Yeah, so of course, like everything else, it's different this year. We're entirely virtual. This symposium, it started back in the early 2000s. The Northern Indiana Weather Service office did one of the original ones, and Indianapolis sort of started taking on the alternate years, and then now Indianapolis is the sole office with the Indiana American Meteorological Society chapter that puts this on. So we work closely with them, and a lot of great speakers in the past. This year, virtually, we're focusing more on some previous events and more on an operational focus from meteorologists. So March 16th, 18th, and 20th, we've picked 3 days to spread it out virtually, because nobody wants to sit in front of their webcam for 8 hours unless they're listening and watching WeatherBrains here.
Yeah,
We
yeah.
may give it a run for its money tonight.
So we're going to take about 2.5 hours on the Tuesday and Thursday evenings, and then about 2.5 to 3 hours on Saturday, and break it up. And we've got some great speakers. The first night, that Tuesday evening, we're going to be focused on nocturnal tornado events, the Nashville event from last year. We've got some speakers from the Nashville office going to kind of talk about that event, and a year later, what's gone on and what's been learned since then. The Jefferson City tornado, that was a great example where the integrated warning team came together and saved lives. So we're going to have some speakers from St. Louis talking about that event. And then when we get into Thursday, and I can't forget the Memorial Day 2019 event that moved through central Ohio, one of the largest outbreaks in Ohio. And, those storms moved across Indiana and for the most part behaved themselves. We had severe thunderstorms. We didn't really have had no tornadoes, a few circulations, but boy, once they crossed the state line, they really spun up and did some significant damage. So we're going to have some talks on that. Then as we get into the Thursday session, that's going to be more focused on the 2020 derecho event that moved across Iowa, Illinois, and sort of faded as it moved across Indiana, but was still significant. Just incredible video and sustained winds from that event. I've been doing this for 30 years and I've never seen anything like that. 35, 45-minute, I think even in some cases 60 minutes of these sustained 60, 70, 80 mile per hour winds, just unbelievable. So we've got several talks scheduled on that. And sort of on that, to wrap up that Thursday evening, Dr. Victor Gensini from Northern Illinois is going to talk about his research and sort of the subseasonal severe weather forecasting. And then finally on Saturday, that's going to be sort of a hodgepodge of a severe weather event. We're going to go through a mesoanalysis of an event we had last year, what we were looking at, forecasting it, how it evolved. We're going to go through radar analysis and kind of go through the warning process of what we were thinking at the Weather Service office in Indianapolis as that event unfolded. And then we'll have a couple talks after that, wrapping it up. Dr. Robin Tanamachi from Purdue University is going to talk a little bit about integrating research weather radars into atmospheric science education. So that'll be a nice way to wrap everything up with that. So there is a $10 fee, but that covers all 3 sessions, just enough for the AMS to cover their expenses. So it's a great bargain. And anybody that signs up and pays their fee, they will have access to the recordings in case they can't make all 3 sessions. They'll be able to download that and watch it afterwards. So we're excited, and we think it's going to be really great. We're trying to get our attendance up. So if you haven't signed up yet, please go to the Weather Service website in Indianapolis, weather.gov/IND, and we've got a link that goes to the AMS webpage with the registration and more information.
Let me just say that's a great event. I thoroughly enjoyed my time there a few years ago, and the lineup is just tremendous. And that's a great office, Bill, and for everybody else. I walked in, and there was Brian Smith of the SPC, and as I recall, he was doing a little session for the forecasters there, and we had a great talk. But that's a great office. And I was going to ask, on an internal note here, Sam, who's the MIC now at Indianapolis?
Mr. Ted Funk. So many might know him. He was the Science and Operations Officer in Louisville for almost 30 years. And he's done a lot of tornado research work, and he's bringing that knowledge up here to Indianapolis. And he started this past August. Dan McCarthy, many of you know, he retired a year ago in February. And so we were fortunate enough to get Ted in pretty quick. And he's been a great addition. And he was hoping to be able to be that introduction in person and meet everybody, but he'll be doing it virtually this time.
Well, we'll be back in the in-person stuff next year. I'm very confident of that. So we've got Nate and Bill Murray, the AMS and NWA big shots. What's the NWA situation for the fall, Bill? Is that virtual or in person?
I'm kind of out of the loop now in that regard.
I thought you were the tallest hog in the trough.
No, that's Nate. He's the tallest hog in the.
Well, Nate, what's the
trough
deal
this year? I'm the Weather Ready Fest person, so we're definitely not having the Weather Ready Fest in person. We do know that.
We are cautiously optimistic that there will be an in-person component to the meeting, and I think the biggest thing that if you want to have an in-person NWA or AMS or anything else, is to keep wearing the mask, keep doing the distancing, get your shot when when your spot comes up, and keep these trends going in the direction they're going. We're so close on this thing. I was saying at the beginning of the in the pre-show, this is literally the 1 year anniversary the last time I set foot on an airplane, and I'm itching to do it again, and a lot of people are itching to get back to normal. We're this close. We can't let our feet off the gas
exactly
yet. So close. But I'm feeling pretty good. I think the trends are heading in the right direction. Vaccinations, Oklahoma is doing by all accounts, a remarkably good job at getting shots into arms. I think they're opening up to another group tonight, as a matter of fact, or sometime soon. So I think they'll be ready to host us, and I'm hoping, I'm planning on being there, and hopefully we'll be able to have something in person. Our goal is to have a hybrid meeting. So if we can do something in person and you can be there, we want to see you in Tulsa. If you're not comfortable being there, or if you're not in a budget standpoint, your budget got cut for travel and everything because of uncertainty, we still want to have you as part of the meeting. And our meeting chairs are doing a really neat job of coming up with some ways to really integrate these two. So it's not just, there's a virtual component to an in-person meeting, but actually having a truly hybrid meeting. So I'm really excited about where that's going. Abstracts closed last week, and we got a really good number of abstracts, actually a little more than last year, believe it or not. So we're looking forward to doing something in person. I'm cautiously optimistic. Just keep the mask on, distance, and get your shots when the time comes.
How many here have received the shots?
Yeah.
Tomorrow.
2, 3, most of us. Okay.
Wednesday for me for round 1.
Okay, cool. We're getting, like I said, I totally agree. We're getting there. We are getting there. And a lot of you know that I volunteer in healthcare, been doing it for 15 years, and the numbers are looking really good where we are for now. And we just have to stay the course, and we see the light at the end of the tunnel. All right, let's do weather roundup. This is where we go around the horn. Everybody kind of share what's happening weather-wise. And let's go to Raleigh, North Carolina. Raleigh, North Carolina, where it never snows.
No, it doesn't, and certainly didn't much this year. No, we're looking at a nice stretch of weather. It's been really wet around here. We missed the wettest December, January, February here by like 2/100ths of an inch of rain, maybe 2/10ths of it. I mean, it was just not a lot. And it's finally starting to dry out here. We're looking at a week of temperatures in the 70s, low humidities, and not a rain chance in sight through the weekend. So, the ridge.
Yes. Dan, are you in Dallas-Fort Worth?
Yes, I'm in Arlington, right smack in the middle.
We used to live in Plano, Texas. I used to be on Channel 4 News, Dallas-Fort Worth, Griffin Street, downtown Dallas. So tell us about Dallas. I see you're in, and again, you're a space weather guy. You might not pay attention to Earth weather, but I do see that you are in the day 6 convective outlook severe weather risk, which would be Saturday.
Yeah, there are some storms coming up. Right now, to be honest, I am just basking in the glory of typical DFW weather now that we're out of the snowstorm. And things have been in the lows in the mid 40s to, I think tomorrow morning is going to be 50 degrees at sunrise and dipping into the high 60s and even the mid 70s. So I've just been enjoying the sunshine a whole lot, but I do see those storms coming up on the horizon. And Bruce, I have to say that the utility and importance of a weather radio has never been more obvious to me than since I've moved here and lived in Texas, where we have tornadoes tornado warnings, serious tornado warnings, are a much more common occurrence than they are in Michigan. So, yeah. But other than that, sunny until the weekend.
The coldest I've ever been in my life. I'll never forget this. I finished the late news. News director called, said the CBS Morning News wants you to do a live shot for them the next morning on that show, which is fine. It's back when Channel 4 was a CBS channel. They put me on Stemmons, Interstate 35 East at like 5 a.m. The wind chill was -5.
Oh,
To
no.
me, it felt more like -55. I mean, I've never been that cold in my life. In Dallas, Texas, back in the winter, I want to say it was winter of 84, 85, something like that. So we all know that Texas can get cold, and we all learned that again this year. All right,
Like
Sam.
my grandfather used to say, ain't nothing between Texas and Canada but a couple of barbed wire fences.
You got that right. That those barbed wire fences will not hold back the blue norther. So Sam, you got any wild weather in Indianapolis? Tell us about the winter. How did the winter go for you guys up there?
It was a shock. We had pretty high confidence it was going to end up being a wet winter, and with La Nina, that's a classic pattern, but we did not get that precipitation. Temperature wise, snowfall wise, was pretty close to normal, and we're still waiting for the pattern to switch. We got a pretty good rainfall at the end of February. And like I said, beginning of March, we haven't had any precipitation yet. We're 8 days in, and that's the first time in history that has occurred. So we're looking to turn the corner, a bit wetter here, mid to late week into the weekend, and then cooler next week. But so far, pretty quiet. One big snowstorm in February, and that was it for us.
All right. Well, let's see, Jen. And by the way, for those that don't know, Jim is a cat lady. I'm a cat guy. We have a new cat out here in the parking lot tonight. We now have 4 cats, 4 that we're taking care of. So I've not seen your cat in the shot tonight, but I thought of Jen when I saw
you weren't looking.
Yeah, it was everywhere.
Okay.
Moving across the screen. No, I have 2.
Okay, 2. We have 4 now, so we got you beat by 2. So what's happening in Ohio?
It is great here. Waiting on some precipitation end of the week into the weekend, a cooling trend, but I'm going to take this mid-60s. I'm giddy about it, so I'm ready. I had the windows open today, but it's still just a little too chilly. But I wanted that fresh air coming in. But yeah, we're going to get a little warmer here, and waiting for severe weather to start kicking back in. I should be a little bit more busy in radio next few weeks, especially end of this week into the weekend, looks a little bit more busy for the planes. So I have several Kansas and Missouri stations that might keep me a little bit more hopping. So it's gonna be a busy year.
All right, Bruce, what you got going for us? Any wild weather this week?
No, but 10 days from today will be the 96th anniversary of the tri-state tornado, which could have been 25. Now, that was about 3 years before the first commercial radio stations began in the United States of America. So when you think about the tri-state, again, this was a tornado that had no real advance warning, unless maybe somebody at the telegraph office could telegraph ahead down the train line. But there's that great paper in the Electronic Journal of Severe Storms Meteorology. It was just incredible reading that Doswell and Burgess and Robert Johns and Steve Piltz put together this great thing. And I'll share that link with you.
Awesome, man. Those guys are legends. And Bill Murray down here in the Deep South, we might do 80 later this week. Bill will be out with his tank top and flip flops. So if you see Bill,
and don't forget black socks, James.
Yeah, black socks, exactly, and dress shoes instead of the flip flops. But we do have the first really convective situation, maybe of the spring coming up in terms of severe weather for the old dry line, the old West Texas dry line will be firing up Friday, Saturday, Sunday, and we'll be kind of watching that. So, but Bill, I hate to do this, but I have to go to Studio A, so I'll let you handle the picks of the week as we wrap things up tonight.
Yeah, that's great. And the Weather Roundup is brought to you by Tim Vasquez's Forecast Lab on YouTube. So please check out Forecast Lab over there if you're remotely interested in weather or certainly learning about the weather. It's a great place to get real-time forecasting experience that you can put into context. And Tim does such a fantastic job explaining it. So check out Forecast Lab for sure. So yeah, I guess it is time for Picks of the Week. I'll start in the upper left-hand corner of my screen with Jen Nairmore. Jen, what you got for us?
So our friend Pecos Hank has a new video, Tornadoes of 2020. Is it over yet? What is the name of it? And he goes through the highlights of 2020 weather-wise. There were some tornadoes that he covered in the early part of the season for the Easter outbreak, and a lot of lightning video in there as well. So check that out. It's about 20 minutes long.
And that raises an interesting thing that I'll ask Dan real quick. Any tie between space weather and sprites? Are they enhanced when there's certain, levels of atmospheric activity, or do you know anything about that?
I don't know the answer to that. I'm so sorry.
No, you've given us so much information tonight. We're just seeing how far we can test the limits, Dan. So we appreciate it.
Anytime.
All right, I'll go to Bruce Jones. I bet Bruce always has one of the best picks of the week.
Well, I kind of threw it out there with the tri-state tornado, but looking over here on my bookshelf, I have two of Tim Vasquez's books over here that I should reach over there and grab because they're a great investment. They really are. I'd say Tim Vasquez has done a wonderful job over the years in all the little seminars that he's done, and so I'm glad to hear that he's doing something online now. That's great.
Yeah, he is a great guy, and I'm excited to have him be part of the show, just like we are having you be part of the show. So I thought we were going to get a twofer out of you there, Bruce, but we'll take that. We'll take that single right there for sure.
All right.
So Nate Johnson, hope y'all are getting to feel better over there after this little cold passes.
That's right. We're doing good. In honor of tonight's topic about space weather, my fascination with aviation. There is an aviation community dashboard on the Space Weather Prediction Center's website. Talks about just sort of a heads up, very high level of AP indices and auroral forecasts and that sort of thing, and some other things with a more aviation bent to it. So nice first place to start if you're looking for potential aurora activity.
Outstanding connection to aviation, which Nate always gives us. Nate, thanks for that. Sam, we'll go to you. What do you got for pick of the week?
Well, Nate kind of stole my thunder a little bit there. Yeah, the NOAA Space Weather Prediction Center, they actually have several really cool dashboards. And in addition to the aviation, they have the space weather enthusiast dashboard. So they've done a lot on that website over the last several years. And you can really learn enough to be dangerous. But a lot of what Dan talked about, you can see some of those images, the GOES solar X-ray imager is just really cool to watch and see those solar flares. And then I'll give you a twofer. I got to throw in the plug for the Symposium website. So all of our information and more bios about our speakers are on that Symposium website. And again, you can get that off the Indianapolis National Weather Service webpage. And
it looks like you'll have us out of there on Saturday in time to watch some basketball.
Absolutely. It's virtual, multiple screens,
Yeah, Owen Isaacs asked us this tonight before the show started, who are our teams? And for me, it's Alabama. We've got one of the better teams we've had in a long time. So we're going to be pulling hard for Alabama starting in the SEC on Friday against Kentucky, and hopefully getting a good seeding in the NCAA. So that's going to be exciting. So hopefully they'll show up and do well there.
I got to plug the Boilermakers, the only team from Indiana that'll probably be in it. So,
is NC State going to make it this year, Nate?
You're going to have to make a run in the conference tournament this year. I don't know, the way they've been playing the last 3 weeks with 5 straight wins, and we've had 5 straight road wins as well after losing our best player about 3 weeks ago. So teams really come together. We'll see how it comes out. App State has made the tournament. The little team that could. That's the team that took down Michigan a few years ago in the Big House and whatnot. So I wouldn't bet against App State. In a tournament setting, that could be kind of fun.
That's exciting. So how about Penn State? Jen, we hear a lot about the Big Ten this year. Are they doing anything in basketball?
I have no idea. I've not even followed. And I know, and I'm a huge basketball fan because I'm from Indiana. So I think we should have Sam back on the show because I want to just grill him on Indiana tornadoes. I have one. I'm probably going to burn his email up with some questions on September 20th, 2002, that long track Indiana tornado. I'd really like to talk to you about that. But I love Indiana basketball, but I have really not been following basketball this year. I've been really absorbed in other things like tornado history. So
I'm still mad at them for beating Alabama in the 1974 Sweet 16. So I'll stay mad about that. Are you a Michigan fan, Dan? Are you? Is that?
Oh yeah, yeah. I did
They've got a pretty good team this year.
They're looking pretty good. Makes up for the football team, and being a Detroit Lions fan, and you need something.
Well, we really enjoyed having you on the show tonight, Dan. I know you've got a pick of the week for us.
Well, I'm going to echo the Space Weather Prediction Center's website that Sam and Nate mentioned. I will focus a little more about the upcoming Space Weather Workshop. Is online this year. Registration is free. There's an excellent student day for students out there who want to get involved. It's a fantastic conference. It's a mix of high-level talks from government and industry, as well as some stuff that's really, really in the weeds. So I certainly recommend that, and it's one of my favorite conferences to be involved with at any level.
Well,
So
that is outstanding. We'd love to have you back anytime to talk about news and notes from the space weather world.
Thank you guys. I really enjoyed this, and I greatly appreciate being able to join this podcast. And congratulations on going on for so long. That's really cool.
Yeah, some people would say too long, but we're still going to keep doing it no matter what they say. So my pick of the week is our friend of the podcast, Jeremy Bowers. He's conducting an AMS webinar, free webinar on photographing thunderstorms and lightning. And we know that will be an outstanding program. So I've sent the link to JP, and we'll have that up on the show notes that'll go up later tonight, early tomorrow morning. So if you get a chance, check that out. I want to thank all of our sponsors. Tim Vasquez. I want to thank the AMS, the Weather Band. I've joined the Weather Band. I've been excited about it since it was announced. Waiting on my bling to come, my guitar pick, key ring, and all the other cool things. And if you don't subscribe to Weatherwise magazine, there's a 40% discount for being part of the Weather Band. So please join that. And of course, Bruce, I bought my first weather radio in November of 1976. I think I paid $49.95 for it at Pizitz, and now they're cheaper than they were then. And you're virtually giving them away. When are you going to wear the barrel? You've given away everything but your shirt.
Yeah. Well, I remember some of the very first SAME radios. Radio Shack had one that sold for, in the equivalent of today's dollars, it was $98 in 2021 dollars. So. These things used to be very, very expensive, really, but they're cheaper now than they've ever been, more affordable.
That's a great thing.
Better.
So thank you in Midland for your sponsorship. Our show next week, we will feature Tim Marshall talking about tornadoes from an engineering standpoint, because the Fultondale tornado was a wake-up call for some of us in the hotel business, having pretty good tornado plans. And we'll actually have the general manager of that hotel join us for a period next week, because she is a story in having a good tornado plan. And we'll talk about making sure that you as an individual traveler develop a plan for yourself, and that all hoteliers and all businesses need to do the same thing. And so I think the Fultondale tornado actually provided a couple of lessons. So we'll be talking about that. But if there isn't any other business to bring around the big digital WeatherBrains mahogany table tonight, Nate, I'd take a motion that we adjourn. What do you say?
So moved.
All right. And I don't think I need a second, but WeatherBrains is the weekly netcast. It's all about the weather. We again thank all of our sponsors. We record each Monday night at 8:00 Central Time. It's labor of love. We've been doing for 16 years now. Dr. Daniel Welling, thank you. Sam, thank you for joining us. It's been great. If you're new to the show, you can access it in a variety of ways. From iTunes and Stitcher to AlabamaWX.com, our website, Big Brains Media, of course, all the different platforms that you can consume your podcast from. And all of our social media accounts are on the website, WeatherBrains.com. We'd love to have a guest suggestion, a comment, a like, or a rant. Send those to email at WeatherBrains.com. But till next Monday night, for the entire panel, this is Guest Booking Officer Bill Murray telling you to keep an eye to the sky, because you'll always have something fun to look at. And we will hope that it is not an aurora in Birmingham, Alabama, Dan. So I'll go to Alaska or Reykjavik or somewhere to see mine. Thank you. All right, guys. Well, thank you. Jen,
Thank you, guys.
Any word from? I should have brought up what y'all are doing, Jen. Any news from Tornado Talk? What you guys?
Yeah,
doing?
we got the website launch with the new membership on Saturday, and it's now membership based. We also launched our Tornado Talk store, and we already have folks who are helping, and we are now focused on the super outbreak project. I would not be surprised if it's not 70 summaries that are going to come out from the end of March through May, covering some of the big events from the super outbreak. So we've been busy, but it's a lot of fun. It's very exciting, and it's a labor of love for all of us. And so we're excited to see how we continue to grow. And I'm so proud of everyone who's working with me, and just the folks who have decided to partner with us to keep this website going and keep us growing. So it's been great.
That's outstanding.
Thank you for asking.
Yeah, thank you for being a part of the show, and for being the official voice of WeatherBrains for all of our
You're welcome.
voiceovers. Thank you. All right, guys. Well, we'll talk to you next week.
All right. Bye.
Bye, everybody.
Thank you.
Bye.
Bye.
All right, guys. Great show tonight. Space weather. Great fun. Got to make it quick. Thank you guys for watching. We'll see you guys next week for WeatherBrains.